Last chapter, linear motion. Now, motion is the movement of an object from one point to another. This movement may be along a straight path or a curved path. Motion along a straight path is said to be linear. The length of the path traveled is called distance. Distance is commonly measured in kilometers and meters. Speed is the ratio of distance traveled and time taken. Mathematically, speed is equal to distance over time. Time is measured in hours and seconds, and therefore speed is given as kilometers per hour or meters per second. So if a car traveled 120 kilometers in 3 hours, its speed is going to be 120 over 3, which is equal to 40 kilometers per hour. If a body covered 500 meters in 20 seconds, then its speed will be 500 over 20, which is equal to 25 meters per second. This means that for every second, the body travels 25 meters. A higher speed means the distance is covered within a shorter time. Average speed. Now imagine a car traveled from town A to town B 300 kilometers apart and took 6 hours. From our previous explanation, speed will be 300 over 6, which is 50 kilometers per hour. This means that for every 1 hour, the car traveled 50 kilometers. However, in reality, this is usually not possible because the road is not even. It means there are places the car would travel slower than 50 kilometers per hour and faster in some other places like downhills. And so the most accurate term is average speed. Average speed is given by total distance traveled over total time taken. For example, a car traveled from town P to Q 100 kilometers apart and took 1.5 hours. It rested for 30 minutes and continued with the journey to town R 50 kilometers from Q and took 1 hour. Calculate the average speed for the whole journey. In the solution, total distance is 100 kilometers from P to Q plus 50 kilometers from Q to R. That gives us 150 kilometers. Total time taken includes the time of rest. 1.5 hours plus half an hour plus 1 will give us a total of 3 hours. And so average speed is 150 over 3. That gives us 50 kilometers per hour. Sometimes you may be required to give the speed in meters per second. We know that 1 kilometer is equal to 1,000 meters and that 1 hour is equal to 3,600 seconds. Knowing that, we can convert the units rather easily. For example, express 80 kilometers per hour in meters per second. 80 kilometers per hour means in 1 hour, the body covers 80 kilometers. And so 80 kilometers will be equal to 80 times 1,000 meters. 1 hour will be equal to 1 times 3,600 seconds. If you divide either side, the left hand side will be 80 kilometers per hour is equal to, if you divide the right hand side, you will get 50 meters per second. Now, if you consider this part alone, it will give us 1,000 over 3,600. If we simplify that, we get 5 over 18. And so to convert kilometers per hour into meters per second, we multiply by 5 over 18. And so 90 kilometers per hour will be 90 times 5 over 18, which is equal to 25 meters per second. To convert meters per second into kilometers per hour, we simply multiply by the reciprocal of this fraction, that is 18 over 5. And so 40 meters per second will be 40 times 18 over 5, and that is 144 kilometers per hour. Next, distance time graphs. A distance time graph is a graphical representation of the distance traveled and the time taken. In a distance time graph, the distance is represented on the vertical or y-axis and time on the horizontal or x-axis. For example, if the distance in meters traveled by a cyclist along a road and the time taken in seconds were recorded, such a table can be obtained. Plotting these points, we shall obtain such a graph. The graph is linear. If we choose any 2 points, say A and B, and calculate the gradient, change in y over change in x, this time we'll be calculating change in distance over change in time. The gradient we obtain is 1.5 meters per second. In a distance time graph, the gradient of such a graph gives the speed of the body. Next, acceleration. Now consider a car starting from rest. In the beginning, its speed is 0. But on the road, the car gains in speed with time. The rate of change of speed with time is called acceleration. Again, when a speeding car slows down and finally comes to a stop, its speed reduces with time. This is negative acceleration or deceleration or retardation. Acceleration is equal to change in speed over time. That is final speed minus initial speed over time. That is given as v2 minus v1 over t. Acceleration is given in meters per second squared. And so if a car changes its speed from 20 meters per second to 50 meters per second in 10 seconds, then its acceleration will be 50 minus 20 over 10, which gives us 3 meters per second squared. Let's take an example. A car traveling at 180 kilometers per hour applies brakes and comes to a stop after 25 seconds. Calculate its acceleration. First thing we do is convert 180 kilometers per hour into meters per second. 180 times 5 over 18 will give us 50 meters per second. Initial speed is 50 meters per second and final speed is 0 meters per second. So acceleration is equal to 0 minus 50 over 25, which gives us minus 2 meters per second squared. And so the car was decelerating or retarding. It should be rather obvious really that when an object travels at a constant or uniform speed, acceleration is 0. Next, relative speed. Now consider a person sitting inside this room. Everything in this room looks stationary. But wait, when he raises the curtain, the trees outside appears to be moving. Actually, this guy is in a caravan. Relative speed is the speed of one object relative to another. Inside the caravan, everything looks stationary even though we know they are actually moving. The reason they appear stationary is because all of them are moving at the same speed, and so their relative speed is 0. Looking outside, the trees are moving in the opposite direction. We know trees don't move, their speed is 0. But because the truck is moving or it has a speed, it introduces a relative speed. And so ideally, the trees can be thought of as moving with the speed of the truck but in the opposite direction if we think of the truck as stationary. Consider two cars A and B moving in the same direction. If B has a greater speed than A, then over time B will gain some distance over A. If it started behind A, it will overtake it at some point. The relative speed of bodies or objects moving in the same direction is the difference between their speeds. Suppose A is traveling at 60 kilometers per hour and B at 90 kilometers per hour. If they traveled for say 1 hour, let's find the distance between them. Method 1. We calculate individual distances and then calculate the difference. A. Distance is equal to speed times time, that is 60 times 1, that is 60 kilometers. B. 90 times 1 hour gives us 90 kilometers. The difference between them is 90 minus 60, which is 30 kilometers. And so after every 1 hour, we gain 30 kilometers over A. Method 2. Using relative speed. Relative speed is the difference between their speeds. 90 minus 60 is 30 kilometers per hour. Distance is speed times time. 30 times 1 gives us 30 kilometers. The same answer. Let's take an example. Bus A leaves a town at 9 a.m. and travels at a speed of 80 kilometers per hour. At 10 a.m., another bus leaves the same town and travels in the same direction at 120 kilometers per hour. Find A. What time the second bus will catch up with the first one, and B. How far from the starting point will the second bus catch up? In our solution, A. B leaves after A had traveled for 1 hour. We find how far A was by the time B took off. Distance is equal to speed times time. 80 times 1 gives us 80 kilometers. And so by the time B was starting its journey, A had traveled 80 kilometers. And so to catch up, B must gain 80 kilometers over A. How long will that take? Remember, while B is trying to catch up, A is still moving. It hasn't stopped. We use the speed B will be gaining over A. That is relative speed. Relative speed is equal to 120 minus 80, which is 40 kilometers per hour. That means every 1 hour, B will gain 40 kilometers over A. So how long will it take it to gain 80 kilometers? Time is equal to distance over speed, that is 80 over 40, giving us 2 hours. So B will catch up with A after 2 hours. What time will that be? We calculate from the time B left the town. That is 10 a.m. plus 2 hours is 12 p.m. So it will catch up at noon. B. How far from the starting point will the bus catch up? We find how far the buses will be at noon. You can use either of the buses. A has traveled for 3 hours at 80 kilometers per hour. That is 9 a.m. to 12 noon. And B has traveled for 2 hours at 120 kilometers per hour. That is from 10 a.m. to 12 p.m. The distance will be the same. That is for A, distance is speed times time. That is 80 times 3 is 240. Or for B, 120 times 2 hours is again 240. You may have experienced relative speed when overtaking another car. Your car appears to be traveling a bit slowly. Now, consider these trucks traveling in the opposite direction. The relative speed of bodies traveling in the opposite directions is the sum of their individual speeds. For example, a car left town A at 8 a.m. and traveled to town B at 60 kilometers per hour. At the same time, another car traveled from town B towards A at 90 kilometers per hour. If A and B are 600 kilometers apart, calculate A, how far apart they are after 1 hour. B, at what time did they meet? And C, how far from B did they meet? A, how far apart are they after 1 hour? We find how much distance they have traveled in 1 hour. Relative speed is the sum of the two speeds. 60 plus 90 is 150. Distance is equal to speed times time. 150 times 1 hour gives us 150 kilometers. So the distance remaining is 600 minus 150, which is 450 kilometers. B, the time they met. Relative speed is 150 kilometers per hour. Time taken to cover 600 kilometers will be given by distance over speed, which is 600 over 150, giving us 4 hours. So they will meet after 4 hours. We add that to 8 a.m. and we get 12 noon. And finally C, how far from B did they meet? The journey took 4 hours. How far had the car from B traveled in 4 hours? That is what we are looking for. So B has a speed of 90 kilometers per hour. The distance it covers in 4 hours will be given by speed times time. 90 times 4, giving us 360 kilometers.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.